So these are very simple equations. Very simple equations, but do write them out, seriously. You're going to want these written out for later on. To solve for x, in this equation, you're just going to add 1 to both sides. So you've got 2x equals 1. And then you'd simply divide by 2, and you get x is a half. I know these are easy, but write out all the steps. Don't do any of it in your head. Okay? Don't do any of this in your head. Write it out, because you're going to want to have these ones nicely written out for when we take this up a notch. And you want to realize that what we're doing is not complicated, it just looks ugly. Okay? So on this next one, a lot of people see the square root of 3 and think, oh, I've got to square it. I can't have a square root. But leave that. Just leave it. We're not solving for 3, we're solving for x. Now, if we'd seen the square root of x somewhere, yeah, we'd have to start thinking about squaring that to get x. But we're not solving for 3, so don't worry about that square root. Just isolate your x's by moving all your x's to this side. So we've got 2x equals negative the square root of 3. Then cancel out multiplication by dividing. X equals negative the square root of 3 over 2. Okay? And on the last one, remember, when you have something that's quadratic, or actually whenever you have any polynomial, when you have x raised to any power, then you're going to make it equal 0. That'll be step 1, make it equal 0. Step 2, factor it. Then use the 0 product rule. Off you go. Solve that one for me. And do write these out with the numbers. Label them 1, 2, and 3. So make it equal 0. Factor it. And then we use what we call the 0 product. We've got two things being multiplied together and the answer is 0. So we know one of our factors. So either that factor equals 0 or this factor equals 0. Write out all of these steps. That's one solution here. This would give us the solution x equals 1. Okay? So that was sort of kind of middle school level. Oh, no. Maybe this was algebra 1 level math. Okay? Maybe 8th grade, 9th grade math. When we sort of really brought in algebra, when we brought in letters. Today, we're going to take that up a notch and we're going to bring in trig expressions into problems exactly like this. Now, what's important today, what's really going to be important is clearly written out, clear, logical, organized work. Okay? It's really going to help you if you write out your work nicely. So, let's move on to this. Christmas joke of the day. Sorry about this one. It's joke number 6. What did the bald man say when he was given a comb for Christmas? He said, "Thank you, I will never part with it." Okay. Never part with it, you know, right there, yeah, never mind. Okay, right, moving on. Right, we're going to have a race in a second. Okay, so how quickly can you draw the unit circle and name all the angles? So we'll draw the circle together, then don't start naming the angles. Draw this, draw a circle. Cut every quadrant in half, and then put a line above and below. Above and below. So you've got 3 lines in the middle of each quadrant. Okay? Okay. Start naming your angles now. Type into chat done when you're finished. Name your angles in radians.
Ephraim, I have a question for you. You don't look like you're writing. You look like you're playing a game on your computer. Done. Well done, Yamming. Oh, that's awesome. So you were in at about 45, 46 seconds. Okay, and then Nicholas Wynn was next. So Yamming, I missed when you said done, but here's our records for the day. Oh, you haven't beaten period 2, but Yamming, you definitely beat period 1. That one in green, that's me. Some of my students in period 1 insisted on timing me. Now, I know a lot of you are still working on this. Let's make sure you know how to do this. You need to know how to name an angle in each quadrant. We start off by just putting in the denominators because they're telling us what our reference angle is. So our denominators go 6, 4, 3, 2, 3, 4, 6. Okay, so we just whiz around the circle and we put in this is 0, this is pi, and we just put in the denominators. This is basically telling us what our reference angles are. And then in quadrant 1, all your numerators are just pi. In quadrant 2, everything's a bit less than a whole pi. So if it's less than a whole, you get the denominator and take 1 off it, and then you have to multiply it by pi. In quadrant 3, everything is a little bit bigger than a whole pi. So you're adding to the denominator and multiplying by pi. And in quadrant 4, remember what you're actually doing here. This is the terminal ray of the angle, and that's the angle in standard position. And you're actually, what you're doing here, each of these lines is a terminal ray, and you're naming the angle that takes you to that terminal ray. Each of these are less than a full rotation, and the whole way around the circle is 2 pi. And if you want a number to be a little bit less than 2 wholes, then you get the denominator, multiply the denominator by 2, and make it a bit less than that. And of course, we're talking about in pi. So 3 times 2 is 6, take 1 off and you're at 5. 4 times 2 is 8, takes 1 off and you're at 7. And that would be 11 pi over 6. Okay? Right, so now why we need that is we're going to need that when we're solving trig equations. We're going to be getting equations like this, and we're going to be solving them. Now look what x is. We're taking the cosine of x in this one, and this one would be taking the sine of x. It's the input into a trig function, so it's the angle. We're solving for angles, so that's why we need to know what our angles are. Look at this over here. It's telling us that our x, our angle, must be in radians, and it's somewhere between 0 and 2 pi. So what we're going to do is we're going to take this equation and we're going to say which angles, as I go all the way around the circle, which angles on here, which of these angles, you know, are going to make this equation be true. And I can include, when all this part is staying, I can go start at 0, and an answer can be the angle 0, and it can be any angle up to, but not including 2 pi. Okay? So, do you recognize this equation? It's this. It's based on that. It's based on question number 1 from the warm-up. It's exactly the same thing, but we're not going to solve for x to start with. We're going to solve for the cosine of x. When you're solving trig equations, step one, solve for the trig function. Once you solve for that, then find the angle or angles. Okay, that's what we're doing. So
First of all, we're going to solve for the cosine of x, so we're going to get rid of -1 by adding 1 to both sides. We've got 2 times the cosine of x equals 1. Please write these clearly and neatly in your notes. The next thing we're going to need to do is cancel out multiplying by 2 by dividing by 2. So there, we've done step 1. We've solved for the trig function. We've said the cosine of x equals 1/2. Now, step 2, this is an angle. We've got to say which angles have got a cosine of 1/2. And we're only considering these angles here. So this is the sort of problem we could have given you about a month ago. We had a whole worksheet called Finding Theta. And how we actually do this part, how we do it at our school, is we say a cosine is a ratio of 2 side lengths. A cosine is x divided by r. Now this x is not the same as that x. This is the angle, that's the side length. So it's a little confusing. Okay? So we draw a graph. This is your x-axis, this is your y-axis. And we are going to be, this is not quadrantal, it's going to be one of our special triangles. And if this is positive, then our x must be positive because r is always positive. So if x is positive, I'm going to the right. So I'm going to draw an angle going to the right, and I can get one in quadrant 1 and in quadrant 4. And I know that my x is 1. So this length of the triangle here is 1. And I know my radius is 2. So I know this hypotenuse is 2. And now I have to look and see, the way we teach at this school, is that a 30, 60, 90 triangle, or is that a 45, 45, 90 triangle? In a 30, 60, 90 triangle, the legs are 1, the square root of 3, and the radius is 2. In the 45, 45, the legs are 1 and 1, and the radius is the square root of 2. Well, our radius is 2. This is the one that lots of people think it's a 45, 45, 90, but it's not. This was actually a 30, 60, 90 triangle. That third leg there would be the square root of 3. So this angle here, opposite that long leg, that's your 60-degree angle. Okay, that's my reference angle. And in radians, that's pi over 3. Now, what we want to solve for, we're solving for this angle here, this x here, that's the angle. Angle x. So we want to know what angle takes me to that terminal ray. I have to name that angle. And I have to name this angle going around here. So my angle, I know my reference angle is 60 degrees pi by 3. So I know my denominators are going to be in 3. In quadrant 1, this solution is in quadrant 1. My numerator is pi. This solution is in quadrant 4. So my numerator must be 5 pi. Okay? Right, let's try the second one here. This was like question number 1 in our warm-up. This was like question number 2 in our warm-up. Look at what we did. Remember, this was the one where I said, leave this alone. Leave it. There's nothing wrong with it. Don't square it just because you can see a square root. It's just a number. Don't be scared of it. What we're going to do is we've got 3 sine x's on this side and 1 sine x on this side. Just bring all of your, we're going to solve it for the sine of x. So bring all of your sine x's to the same side by subtracting sine x. Okay, so it's just how we solved the problem on number 2 in the warm-up. Now cancel out multiplying by 2 by dividing by 2. And now we're at a problem, the sort of problem we could have given you a month ago. Find the angles x. Which angles have got a sine of negative root 3 over 2? Remember, a sine is the ratio of the side lengths y divided by r. If my ratio is negative, it must be the y that's negative. And if y is a negative, I must be in quadrant. If y is negative, I must be going down. I must be in quadrant 3 and quadrant 4. I know my y is negative the square root of 3. I know my r is 2. And those are 30, 60, 90 triangles. This angle here must be the 60-degree angle again. That's my reference angle. Look back to this line here. What am I solving for? I'm solving for angle X. So name those angles, the angles that take me to this terminal ray and this terminal ray. This angle, it's based on 60 degrees, which is pi by 3. My reference angle is 60 degrees, which is pi by 3. When I'm in quadrant 3, I've named that angle 4 pi over 3. When I'm in quadrant 4, I'm going all that way around. It would be 5 pi over 3. Hope you're able to keep up with me. We've got quite a few examples to get through today, and they're all important. Please try to write your work out neatly. Don't cram it in a tiny little space. Let's try another one, and guess what it's going to be based on? Question number 3 in the warm-up. Ooh, what's happened here? Ah, I know why I've got that down there. Do you remember question 3 in the warm-up was x squared equals x? That's what this means. A little note to yourself. Note. If you see written cos squared x, what that means, it means the cosine of x squared. It means the cosine of x multiplied by the cosine of x. We cannot write it like this, because that means the cosine of just the x being squared. That's not what we're talking about. That's why we put that little squared symbol here. Okay? So we've got something that's quadratic here. Let's make it equal 0 by subtracting the cosine of x from both sides. And you can't have, if you had like x squared minus x equals 0, you can't subtract x from x squared. They're totally different things. So what we have to write here is cosine squared of x minus cosine of x, and it would equal 0. These two cancel each other out. Okay? Now, it's quadratic. We made it equal 0. Our next step is to factor it. Some people get really confused when they see the words. Factoring is hard enough for some people. This next part is optional. I'll do it in red. This is optional. You can put in a substitution. Choose any letter you like. Let's use, well, that's not x, so use x. Let's use m. M for Merry Christmas. Let m equal the cosine of x. Now this is the cosine of x squared, so that would be m squared. Then we've got minus, this is m, then we've got equals 0. That might make the factoring seem easier. On a hard one, this isn't a particularly hard one, some of them get much more difficult than this. So that is factorable by taking out the GCF. And this tells us that we know that, oh, we could write the cosines back in again now. To factor that, it's simply cosine of x times, I'm replacing the m's back with the cosine of x. The bit in pink was optional, but if it's difficult to factor for you, then do that substitution. It's more to write out, but it helps. Okay? So this gives us cosine of x must be 0, or the cosine of x must equal 1. How do we solve that at this school? Let me move some of this up. I need more room on my page. Okay. Cosine of x, that is a ratio, cosine is a ratio of x divided by r. Remember, if your x or your y is 0, that's quadrantal. And on this one, we've got cosine of x, that would be, this is also quadrantal. If one of the legs is 0, it's quadrantal. If one of the legs, the x or y is the same as the length of r, that's also quadrantal. I've got two solutions here. Let's graph them. When it's quadrantal, you draw a circle of radius 1, and you don't draw a triangle. So when it's quadrantal, let's make a note. I know some of you can't remember this. If it's quadrantal, you know it's quadrantal if x or y equals 0, or if the length of x or the length of y is the same as the length of r. If it's quadrantal, do not draw a triangle, because it's not 30, 60, 90, or 45, 45, 90. Instead, draw a circle of radius 1 and look for points with the right x, y coordinates and name the angles that reach those points. Okay, that's what you do if it's quadrantal. So on this one, what we know, we've done a circle of radius 1, we know our x has to be 0. Where on this circle are points with an x value of 0? Well, there's two, this one here and this one here. Now we have to name those angles. How we name the angles, I'm talking about the angle that takes me there to this terminal ray and the angle that takes me to this terminal ray. So what's the name of my angle? Look up here. What am I solving for? This is critical. Write down what you're solving for. My angle is called x, and it equals pi over 2 and 3 pi over 2. And then on this one, try that again. You name the angle for that one. Again, this one's quadrantal. So draw a circle of radius 1. And this time we're looking for points on that circle with an x value of 1. It's just this one. This is the point 1, 0. This is actually the point -1, 0. We don't want that one. We just want this one. Name the angle. That angle, angle x, we could either call it 0, or we could go the whole way around and call it 2 pi. But remember what we were told at the top of the question. We're only solving for values of x from 0. We're not allowed to include 2 pi. So that one's too big. Okay? So that's our solutions to this equation this time. It's these two solutions and that solution. Our solutions are x is 0, pi over 2, and 3 pi over 2. Okay? We've got 3 solutions to this question. Let's try this next one. Let me get rid of all these notes in the way. You can't even see the question, can you? It's quadratic. We're going to have to make it equal 0, then we're going to have to factor it. So, if you want to do a substitution to help you factor it, you may. This is stuff I did in pink on the first equation over here. If you want to, we could say let tangent of x equal, and choose a letter. Why not use t for tangent? This is tangent squared, so it's like t squared, minus 2 times tangent, that's t, plus 1 equals 0. Now it makes the factoring seem much easier. be t times t to give me t squared, 1 times 1 to give me 1. They must both be the same to give me that plus there. They must both be negative. Now, t was standing in the tangent. So this is tangent of x minus 1. Tangent of x minus 1 equals 0. We're going to use the zero product rule. We know that either this factor equals 0 or this factor, and they're both the same. So what we know at this point is that the tangent of x minus 1 must equal 0. Okay. When we're solving trig equations, remember, step 1 was solve for the trig function. So we finished step 1. We found out what our trig function equals. Now we have to solve for the angle that's inside it. We've got to find out what angles have got a tangent of 1. So how could I get 1? That's going to be a ratio. 1 could come from positive 1 divided by positive 1, or it could come from negative 1 divided by negative 1. And remember, when we're talking about tangent, we're talking about the ratio of the side lengths, y divided by x. So on this problem, that's a 45, 45, 90 triangle, where the x and the y are both 1. That's that angle and this angle here. Name this angle. That reference angle is 45 degrees, which in radians is pi by 4. We have one solution for this angle x. We have one solution in quadrant 1, which is just pi by 4. Then we also have a solution in quadrant 3, which would be 5 pi by 4. That was all of the solutions for x's. Okay. How would this question or either of these questions be different if the question hadn't given us this at the beginning? Let's clear out all that extra stuff. If we hadn't been given that, if instead the solution, the question had said solve for all x's. We just looked for going once around the circle. For all x's means you can go around that as many times as you like. Let's take a cosine, for instance. We've just gone from 0. We've done one period of the wave. We've just done that. But we know that this wave goes on and on and on and on and on forever. For all x's, we've got to find all places where that wave, that cosine is at 0 or the cosine is at 1. Let's take where the value is at 1. This angle was 0. Here again it's at 1. That's at 2 pi. It happens there. And the next time we're at 1 is at 4 pi. We could go backwards to here, would be at negative 2 pi, etc., etc., etc. Okay? Let's make a note about what we're doing here. If the question had asked you to solve for all values of x, not just those from 0 to 2 pi, you find these solutions, you get each of your solutions. So on this one, we had x equals 0, x equals pi by 2, and x equals 3 pi by 2. And we have to say this will repeat these will repeat every period of the function. So to each of those answers, I have to add on a multiple of the period. The period for a cosine where this value n is just an integer. Numbers like 1, 2, 3, 57, -28, yeah? N is any integer. Okay, that's what we're doing. If we looked at this one for the tangent one we just did, our solutions were x. This was, remember the equation said the tangent of x equals 1. Our solutions were x equals pi by 4 and x equals 5 pi by 4. And we want the period of tangent so to that we add any multiple of the period. One thing to note, it's not really a big deal. If you write that as your answer, you're fine. You're fine. I just happen to notice when I look at that if you got pi by 4 and you added on 1 pi, that would actually give you 5 pi by 4. So this answer here is kind of really the same as that answer there, but it's not a big deal. It doesn't matter if you've written the answer twice. It really doesn't. Okay? Don't worry if you didn't understand what I just said. That's not a big deal. Just know that if you're asked for all the solutions for all x's, not those limited from 0 to 2 pi, just add on n times the period of the function to each individual solution you've got. Right, time for you to try one on your own. This one's a little tricky. I'm going to make a suggestion. I suggest that you let the cosine of x equal m. So what you've got here is 2m squared plus 3, that's m. It's quadratic, so make it equal 0. Subtract 2 from both sides of the equals. Okay, so I've started that off here. Your next step is to factor it. I'll leave you and work on this for a minute or so, okay? So factor this. Your factors of 2m squared must be 2m and m. Your factors of 2 are 1 and 2. Think about it for a second. If you put 2 there and 1 there, that couldn't work, because otherwise 2 would have been a GCF that you could have pulled out from the equation and you couldn't. So the 2 does not go there. 2 must go here, 1 must go here. This says subtract, so one of them must be negative, and I want to end up with plus 3m. If I put a plus 2 there, this gives me plus 4m, and a minus here, that gives me minus m, which does give me plus 3m. Okay, so there's your factoring. Now, remember that m was just there in place of cos x. So what we've got here is we've got 2 times the cosine of x minus 1, and we've got cosine of x plus 2 equals 0. This gives me 2 cos x minus 1 equals 0, or cos of x plus 2 equals 0. Solve both of these. This would give me the cosine of x equals 1/2. This one gives me the cosine of x equals -2. Cosine is a ratio of x divided by r. If it's positive, I must be going into quadrant 1 or quadrant 4. Have we already had this exact problem sometime today? If your x is 1, that's 1. If your r is 2, this is 2. Okay, that's a 30, 60, 90 triangle. Well, this angle here is 30. Oh, no, it's not, it's 60. My reference angle is 60 degrees, which is pi by 3. In quadrant 1, what am I solving for? Look to your work here. What was the name of my angle? Now, this is critical. You must write down the name of your angle, and you're going to find out why. We're going to take these up a notch in a second. That's the name of your angle. That's what you're solving for. Write it here. If you don't, you're going to get so lost on the next level of question. Okay? The angle is called x that we solved for on this line. In quadrant 1, it's pi by 3. And here in quadrant 4, you're going all this way around. That would be 5 pi by 3. That was the solutions to this part. And then this one. Well, that's not possible. You can't have the leg of a right triangle be longer than the hypotenuse. That's what we call an extraneous, that's an extraneous solution. That would be an impossible triangle. It's an extraneous solution. Okay, if you think about the cosine wave, it goes up to +1, down to -1. At no point does it go down. None of these angles. For none of these angles does that line come down to -2. Yeah. So here are our answers here. Those were our answers between 0 is less than or equal to x is less than 2 pi. Did we need that, or did we need all of them? Look back at the question. Aha. We just needed those limited ones. If it wanted all of them, then here it would have said for all x's, okay, or whatever variable they're using. But we don't have to change our answer. It just asks us for that. Okay? Right. Now these are getting a little tough, and I'm about to take them up a level. This example, we're not going to do this one yet. We'll do this on Monday. We'll do this one on Monday. Don't worry about it. This one here is really important, and I want you to start a new page in your notes. Write this one out beautifully, and don't skip anything at all. So write down the question. What we have here is what we call a multiple angle. Can you see that? We've got 2x. We've got a multiple of our angle. On this, in the past, when I said do the substitution, I said it was optional. This substitution is not optional. It's really going to help you if you say, let 2x equal is an angle. Let's just call it theta. And what we're going to do is we're going to solve for the sine of theta. I'm going to work out what theta is, and then we're going to be able to work out what x is. Now, don't ignore this. This is important. We're looking for 2x. We want 2x there, not 1x. So we're going to have to change what's written there. We're multiplying everything by 2. And we've just said 2x can be replaced with theta. Think about what this means. When we're finding our answers out for theta, we're not just going to go once around the circle. We're going to go once around, find some solutions, but then to each of those solutions, we're going to have to add on another rotation. We're going to have to add 2 pi to every solution. We're going to keep the first set and we're going to get a second set. We'll get the first set in green and then we'll get the second set in pink. Okay, that's what this is going to mean to us. I'm going to erase that out of the way. That's what we're going to do now. Okay, so first of all, let's do the easy part. Let's just solve this for the sine of theta. So dividing by 2, the sine of theta equals -1/2. And we know that sine is a y divided by an r. If it's negative, we must be in quadrants 3 and 4. Here's your y. If y is negative, we're down here, we're down here. So here are my triangles, and my y is -1. And my r is 2. Look at that, recognize what you've got. Are those triangles, are they 30, 60, 90s, or are they 45, 45, 90s? What have we got there? That third side would not be 1. That third side would be the square root of 3. We've got a 30, 60, 90. And our reference angle here is opposite the short side. So our reference angle is 30 degrees. Our reference angle is 30 degrees, which in radians is pi/6. And we've got one solution in quadrant 3 and one solution in quadrant 4. So we're going to name this angle and we're going to name this angle. But this is the point where some of you will go wrong if you're too lazy to do what I'm telling you to do. Look back here. What is the name of the angle we're solving for? We're solving for theta. You must write that here. If you miss this, you're going to get lost in what we're doing. Solving for theta, in quadrant 3, it's going to be 7π/6, and in quadrant 4, it's going to be 11π/6. Those were going once around the circle. Now we have to both of those solutions. So we're going to get that 7π/6. We're going to have to add on another. So that's this one. We're adding on. We've got 7π/6. We also want this angle here. We're going to add on a full rotation. 7π/6 plus 12π/6, which gives us 19π/6. That's our third solution. Okay. I want to move this work out of the way. Sometimes you can do that in your head if you're any good at that. And then for our fourth solution, we're going to get this one and add a rotation to it. So we're going to have 11π/6. We're adding on 12π/6, which gives us 23π/6. Okay. So at this point, we've got 4 solutions, but look at what we've solved for. We were solving for theta. That's not what our question was about. Our question was about x. Now we know that theta equals 2x. So at this point, we know that 2x equals 7π/6, 11π/6, 19π/6, and 23π/6. I don't want 2x. I just want 1x. So what we're going to have to do with all of these is divide them by 2. Now, do not do that. Don't do that. Think about it. If you're dividing by 2, where does the 2 go? Does it go in the numerator? No, that would be multiplying by 2. If you're dividing by 2, it goes down here. So our solutions for x are 7π/12, 11π/6, over 12, 19 pi over 12, and 23 pi over 12. And we're finished. One quick thing to check. In the original question, it said that 0 should be less than or equal to x should be less than 2 pi. Check your biggest answer. Check that largest angle is still less than 2 pi. Because 2 pi would be the same as 24 pi over 12. Okay? So we're happy. Haha. Or maybe you're not happy. Maybe you're kind of horrified. That's a lot. How are you feeling about the lesson? Give me a feeling for understanding. If you're able to keep up with me perfectly, give me a 5. If you vaguely think you got it, give me a 4. If you think, okay, I can do this if I do my homework, I just need to look through it a bit. If I've totally lost you, give me a 2. Okay. Now, if you've got a 2 or a 3, I'm going to repost this video. And you can scan through to find the bits that you want to watch. Here, let me pause this video.